Have you ever wondered how fireworks manufacturers create the different colors of lights in the sky? The answer, of course, lies in chemistry. Let's conduct demonstrations in a controlled environment to look more closely at differences between the colors of light emitted from the elements as they burn. Dr. Lisle has dissolved several ionic compounds in methanol. First, he's going to show you what the flame for pure methanol looks like so you can compare it to the other elements. Methanol, which is a form of alcohol, burns with a blue flame similar to one that you might observe if you cook on a natural gas stove. Next, he has a solution of sodium chloride dissolved in the methanol. If you are driving down the highway at night and you see yellow lamps, those are sodium vapor lamps. The color of flame also depends on temperature, so we might not see the color right away for some of the samples. Each flame needs time to get extremely hot to yield the maximum emission from the metal. On the camera, this sodium burning looks kind of pink, but in real life it was quite yellow. Since you have plenty of sodium chloride at home, you can check this one out live, but make sure you have a controlled environment for containing the flame. Next, let's look at potassium. This potassium solution in methanol burns lavender. Why is each solution burning with different colors? The colors we see emitted as the elements burn are from atomic emission spectra. Remember, the wavelength of those observed colors depend upon the distances between the allowed electron energy levels in the atoms. We are promoting the electrons from the ground state to the excited state using heat in this experiment. Then the atoms emit light as the electrons travel from that excited state back to the ground state, a process that happens spontaneously. The next solution he has is of calcium chloride. It will burn with an orangish red color. Remember that the blue color is from the methanol solvent. This one isn't quite as exciting as the others, and Dr. Lisle hypothesized that it is because the calcium chloride doesn't dissolve as well as some of the other salts in methanol. The next solution is strontium chloride, which emits a bright red color. Does the emission of red light involve a higher or lower energy photon than the emission of purple light? Go ahead and try to answer that question now. Hopefully you said that the purple light was a higher energy photon. The purple light has a smaller wavelength which corresponds to a higher frequency and a higher energy than red light. Next, we have a barium solution. This barium solution will burn apple green. It looks like there's a bit of an impurity in this one. Perhaps it got contaminated with some of the strontium. The seventh flame test we'll do is for a solution of copper 2 chloride dissolved in methanol. Remember, even though copper is a cation with a +2 charge here, it still has 27 electrons that can be moved into the excited state by the heat of the flame, and those can relax back down to lower energies in transitions. Those transmissions emit a bright green light that we can see with our eyes. The last sample is boron, which also emits a green light as it burns. In this case, the boron is in the form of boric acid, which is dissolved in the methanol. Which of these colored flame solutions did you enjoy the most? For the grand finale, we've got all of the solutions burning at the same time. Dr. Lisle and I lit them as quickly as we could to make the most exciting campfire ever. The yellow-orange sodium is front and center. As you have observed in this video, many metals emit a characteristic visible color as they burn. And this fact can be used by analytical chemists as they conduct qualitative tests for metals in samples. This fact is also exploited by fireworks manufacturers, who add particular elements to their mixtures to give the desired color of light upon explosion. I hope you've enjoyed this chemical demonstration of colored flames.